Hello, everyone. Good morning. You hear me?
Yeah, we can hear you. Good morning.
Thank you. So today's the last lecture for this module. And first of all, I want to emphasize that on the Moodle, on the Moodle, in the section of lecture notes, I've uploaded 6 new files, as you see here. So 5 of them are pre-recorded videos, and the sixth one is an Excel spreadsheet. And these 5 pre-recorded videos are about all of them are about how to perform eigenvalue analysis, but each one is about using a different method. For example, the first one is how to perform eigenvalue analysis by using partial differential equation manually. It's hand calculation. I just go through the hand calculations, how we can do it. And then I have done the same example based on e-tabs for the same problem. And finally, I compare all the results based on the different methods. And the next one is based on Excel. The next one is based on MATLAB. And the last one is based on ChatGPT. I try to give this question to ChatGPT and try to get a kind of answer and solution from ChatGPT. And it's an interesting video to watch if we can use artificial intelligence machines to solve our problems or not. The result is somehow challenging. And the Excel spreadsheet is about the stuff I've done during these videos, and I've used this Excel sheet during my videos, of course. So what you can do is, at your best time convenience, you can watch them to get through them. Sorry, and so if I go through the some of the slides just to describe what are those files are. Make it the screen. So actually the example I've gone through is inspired from example 9.1a from the book. It's a two-story building with two lumped mass at two different story levels. And as you know, you have the stiffness and mass matrices, how to calculate them in the book, and we have discussed about these during the past lectures. I also provided one slide here how to use these kind of stuff for uh, for the buildings with more stories than two, which is the case for your coursework. When you want to uh, do your coursework, you will need this slide as well. I've discussed this during those videos as well. And what I've discussed during those videos is really about the eigenvalue analysis. And as we discussed before, um, the eigenvalue analysis is about solving this equation. You should assemble the product of k minus square omega times m, where k and m are respectively stiffness and mass matrices. So in this case, k and m are 2 by 2 matrices, and you need to assemble this and calculate the determinant of this matrix equal to 0 to find the unknowns omegas. That's the whole process you need to do for the eigenvalue analysis. And for this purpose, we have an example of eigenvalue analysis in example number 10.4 in the book, and it is parametric somehow. However, I changed this example to a numeric one. I will get back to the coursework later on. Like this. This is the example I've gone through the those pre-recorded videos. It's a two-story 2D frame structure. The height is 3 meter, and we have two lumped mass at story levels equal to 50 and 80 tons. And it's a concrete frame consisting of beams with the square. They are a square with a dimension of 35 centimeter, and the module of elasticity for the concrete material is 20 gigapascal. This is the example. I've gone through those pre-recorded videos, and this is just the hand calculations for the first video. Uh, is there any questions so far?
No
So,
questions.
uh, is the example clear what we are going to solve? So this is really the definition of the example, and the rest are the solution for the hand calculation. And you will see the description in the first video. Okay. So, and really what I've done um, during those videos is I've comprehensively gone through different methods that I can employ to solve this problem. So take your time and watch them carefully, because before you go for the coursework, of course, because this is needed for your coursework. So at your best convenience, I know today you're going to submit your individual project, and this deadline influences all of your activities. But uh, after your deadlines, whenever you are aiming to solve the coursework, before that you need to carefully watch all of the pre-recorded videos to deeply understand what is this problem. And if you understand them, then it helps you to solve your coursework. So this is what I've done during those 5 videos. First of all, I have gone through the hand calculations, this slide, to see how we can do the analysis with hand calculation. Then what I've done is I've done this with using a kind of finite element tools like etabs. As you know, etabs is a finite element tools and very powerful. So I can do eigenvalue analysis by using etabs. And for this part, for only for this part, probably because of the etabs license, you need to do it in the laboratory in the Nelson. So if you are by any chance today on the campus, you can go to the laboratory and use the computers to solve this part. But the other parts are really uh, doable on any computer, laptop, whatever. For example, with Excel, the next attempt is with Excel that I've tried to solve the problem with Microsoft Excel, which is available on any computer. And the last one is how to use it by MATLAB. And just a reminder for the MATLAB, you can install MATLAB on your own computer or desktop or laptop. The instruction is on the Moodle as well. As far as you have your university credentials, you can log in with that one and create a username with MATLAB, and it works. Um, as a university credential for you as far as you're a member of university. And the last one, as I said, I've tried to inform this question to the Chat GPT and try to see if Chat GPT can solve this problem for me. If it could solve this problem, it should be able to solve the uh, coursework, of course. But I don't reveal the results. You can watch the video to see if ChatGPT is able to solve this problem or the coursework or not. It's an interesting topic to discuss. So I come back to the coursework, part two. I just want to briefly go through the different steps you need to do for your coursework. Before that, is there any questions so far? So if not, I just briefly go through the coursework steps to see what are needed for this coursework. This is the second part of the coursework. So it says consider a 2-bay and 10-story 2D concrete frame. So it is somehow really very similar to the example I've employed, with difference that the example I've solved already is 2-story and your coursework is 10-story. So you need to add 8 more stories to the current problem. And in the current problem, I've dealt with uh, 2 by 2 matrices, but in the coursework, you need to deal with 10-story matrices. So 10 by 10 matrices. So uh, as far as you're using MATLAB, Excel, or eTabs, it's not a problem. And you will see if you watch those videos, it's really easy to deal with them. So a unique set of necessary input parameters is provided for each student via the student parameters sheet. If on the Moodle, when you see the coursework brief, you will also see an Excel spreadsheet describing each student with a set of parameters. I just briefly describe the parameters. For example, the column E here, it's left bay lengths. Uh, so you have 2 bays. Sorry, it's not 1 bay. It's 2 bays. It means you have 3 columns in each story. So the distance between the left column and the middle column is called left bay, and the distance between the middle column and the right column is called right bay. So, for example, for the first student is 3 meter and 3.5 meter. This is the story height, which is uh, identical for all the 10 stories. For example, for the first students is 3 meter. So with these 3 parameters, you know the geometry of your frame. Uh, the first bay, second bay, and the height. And the H column gives you the square column section dimension in terms of millimeter. It means that all the columns have a section of a square shape, and the dimension is 600 millimeter all along the 10 stories. And the mass per story in terms of ton is, for example, this one is 58.5 tons. So you need to put lumped mass at the center of each floor for all the floors equal to 58.5 tons. Is there any doubt on this Excel spreadsheet to describe how you need to use those parameters? If you need any other parameter, like the beam characteristics, you need to make some assumptions by yourself. And to inspire about that, just watch the videos. In the videos, especially in the second one, which I've discussed about the E tabs, you will find how I assume the characteristics for the beam. So with these parameters, you should be able to construct your stiffness matrix and mass matrix. Any question? So I continue with the coursework.
So
Yeah,
I have a question, sir.
yeah.
With the load, do we convert it to distributed load, or we just leave it as tons, or do we convert it to kg or kilonewtons or anything like that?
First of all, you cannot convert ton to kilonewton.
Okay.
Ton is for mass, kilonewton is for force. So uh, because Newton will shake in the grave if you do that, because you know the Newton law, force is mass times g, right?
Yeah.
So, for example, if you have 1 ton mass and uh, it has g as an acceleration, so you can multiply this by g, which is, let's call it 10, and 1 ton times 10 would be 10,000 Newton, right, as a force. So be careful about the definition of mass and force. So here we are dealing with mass, and force is something different.
Yeah, that's not.
Second of all,
Hmm.
yeah, second of all, yes, you need to convert it to kilogram because it's good to work in SI unit system, as I've done during those videos. If you watch those videos, I've converted them, yes. But I just converted the mass into kilogram, not anything else. So you need to multiply these values by 1,000. So they will be in terms of kilogram. And for the rest of parameters, I've worked with meter. For example, for the square columns dimensions, I just converted the millimeter to meter for my calculations in the hand calculation and the e-tabs and the other cases. Does it make sense?
Okay.
Good. So I continue with the steps you need to cover for your coursework part 2. There are 7 steps. We go one by one through them, and I describe what are they. And please let me know if there is any doubt or question in any of them. So for the B1, B stands for the second part of your coursework because we had A in the first part, A1, A2. So how here we have B1, B2, B3. So for the B1 section, it says assemble a stiffness matrix and mass matrix manually. So you need to assemble those matrices manually. And to be honest, you need to use just this slide. So exactly what you have done for the 2-story building, which is available during those videos, you can repeat that this time for your case. Um, by considering 1 degree of freedom for each story, therefore the whole frame has 10 degrees of freedoms. You can assume the total mass of each story at the center of mass in each story. So all of these assumptions are exactly identical to what we have assumed for the 2-story example during those videos. The only difference, the only difference between this B1 and that 2-story building that I've solved during those videos is actually, there are 2 differences. First of all, it's 10-story rather than 2-story. And second of all, it has 3 columns in each story rather than 2 in those example, in the solved example. In the solved example, I have 2 Let me use my pen. I have two columns, but in your coursework, it's like this. It goes up until 10 story, right? It's like this. Go until 10 story. So in each story, you have three columns. So when you're adding the stiffnesses of columns together, in the example, I've added two columns together. In the coursework, you need to add three columns together. Okay, that's the only difference. And you have 10 stories rather than 2 stories. So your matrices will be 10 by 10. Is it clear? So moving to B2. B2 says calculate eigenvalue and eigenvectors by using Excel. B3 says using MATLAB. B4 says using ETABS. So these three sections, B2, 3, and 4, are exactly like those videos I've gone through to solve the problem by Excel, MATLAB, and ETABS, right? As you see, I haven't asked you about solving the problem manually in the B1. In the B1, I'm only asking you to assemble the matrices manually, okay? I'm not asking you to solve them manually because it doesn't make sense because it's 10 by 10 matrix. So manually, it's really hassle and it doesn't make any sense to do it manually. So if you solve it by those Excel, MATLAB, and ETABS, and the results are the same, it means that you're doing well. So I'm only asking you to do it by Excel, MATLAB, and ETABS, and the instructions are available through those videos for that example of 2 stories. Does it make sense? Is it clear for everyone? If so, in the section B5, it says discuss and compare the results obtained in steps B2 and B4. Not and, B2 to B4. It means that B2, B3, and B4. So it's exactly what I've done during those videos as well. So what I found during those videos, you will see is that what you get as a result from Excel and MATLAB, they are really identical, very the same. But there is a little difference between those Excel and MATLAB with the results you get from ETABS, and there is an underlying reason for that. The difference is not too much, but there is a little bit difference, and you need to compare those values and report the difference and discuss the reasons that you think the difference is coming from. So this is about B5. B6 says, how can you approximate this 10 degrees of freedoms framed by a single degree of freedom system? As we discussed in the lectures, the first mode contributes mostly on the final deformation, and that's why you can answer this question that I can approximate my 10-story building with a single degree of freedom system with the with the period, natural period, equal to the first natural period of the 10-story building. So you will assume that you have a single degree of freedom system with a natural period t. This t should be equal to the first natural period of that 10-story building. This is an approximation of your whole building. And then with this approximation, you proceed to the section B7 to apply an arbitrary initial condition, uh, initial displacement and velocity, of course, for both the 10-story and single degree of freedom system and compare the displacement history of them. Discuss on the results. What you will do in B7 section is that you have two different structures. The first one is your 10-story frame building that you have used for different purposes from B1 to B6. And the second one is the idealized single degree of freedom system you came up with in section B6. So a one a one thing a single degree of freedom system and 10 degrees of freedom system. So for both of them, you need to enforce an initial condition like an initial displacement and velocity at t0 I mean at time equal to 0, and calculate the free vibration response for both structures and compare them to see what are the results. For this purpose, for this purpose, for the single degree of freedom system, you can use the Excel sheet I already supplied on the Moodle for the single degree of freedom systems. If you remember, we have, let me open the Moodle to just take a look at the page. On the Moodle, we have this Excel file, see? Single degree of freedom, free vibration, right? Single degree of freedom, free vibration. Uh, you need to, you can use this free vibration to solve your single degree of freedom system. So you need really just to change the period of vibration, nothing else, and the initial conditions if you want, and you will get the response. So if I just open it, you will see just a recap with, yeah, it's here. So if you remember, it was M and K and damping. So it's only okay if you play with M and K just to come up with certainty and that you're desired to have. And these two are the initial conditions you want. And with this, you can have your response versus time, single degree of freedom, vibration, undamped or damped over time. This is the response, the deflection, the deformation of a single degree of freedom system over time. This is wrong. This is not undamped. This is damped. And this is for your single degree of freedom system. But let's move to PowerPoint. Uh, so for the single degree of freedom system, you can use that Excel sheet. But for 10 degrees of freedom system, you cannot use that Excel spreadsheet. And this is the part of the coursework you need to do a bit of research to see how you can calculate the response of 10 degrees of freedom system in your case and compare it with the single degree of freedom system. But as a hint, one possible option would be to use ETABS for this purpose. You can use ETABS, the exact model you have constructed in B4, in a step B4, to calculate the response history of your 10 degree of freedom system. And whenever you have done that, you should compare the response history of 10 degree of freedom system with the single degree of freedom system and compare them. The comparison between these two responses uh, makes it uh, make a foundation to judge about the accuracy of B6, because in B6 section you have idealized your 10-story building with a single degree of freedom system. So the B7 section will approve if this assumption is correct or not. In B7 section, you're simply comparing the response of a single degree of freedom system with 10-story building system, and you will see how close they are together. The more close they be together, the more accurate the assumption in B6 section is. And this is the sort of discussion I anticipate from you in the B7 section. Is this clear for everyone?
Yeah.
Good. So the important notes at the bottom of the coursework part two, just please read them carefully. It states that whatever you have used for your coursework, you need to upload with your report. Like when in the section B4, when you're using etabs, okay, you need to uh, attach your etabs files, and for the etabs files, don't forget that you need to provide the extensions of EDB and $ET, because if you don't provide $ET, it is probable that I cannot open it properly. It's the matter of different versions. And if you're using Excel for uh, B2 section or MATLAB for B3 section, just you need to provide the files with your report, and your report doesn't have any limitation, but it should make sense. Just do not provide mass output like um, those tables or numbers that do not make sense. You should provide some engineering uh, kind of results that make sense, and you need to discuss on any kind of results you obtain, you provide in your report. And as everybody knows, your report, you should be original and your own work, and should be done from 0 to 100 by yourself, not copy and paste from anywhere. If you use any reference, you need to cite it properly into the text or bigger table captions. You should not use any source of data without citation. So this is the explanation of the coursework. Is there any question for this part? Uh, the next point I want to emphasize is that today is the last lecture. So the next week, uh, the next week Friday is uh, Good Friday, and it's off. So we will not have any lecture next week. However, we will have a revision session before your final exam. It will be, I will circulate an email about this later on, probably next week. It would be early May, because as I remember, your exam is on 9th of May. So it will be a couple of days before your exam. So you will have the opportunity to discuss any questions or discussions you have. So um, just as a question, um, is there any problem or other activities you will have if if I want to do it on 4th of May, for example, it's Thursday. It's Thursday, 4th of May. Is it okay for you? At least you're present in the call. Just take a look at your calendars if you have any other lectures or revisions or whatever. Probably I'm going to do it on 4th of May in the morning, like 11:30 until 1:30, or no, or 12 until 14, something like this. Does it work for everyone present in the call? If if I don't hear any objection, I assume it's okay. So
Sorry, would you
yeah,
would you be able to repeat that date and the time?
yeah, it's my suggestion is 4th of May, since your exam is on 9th of May. So see, um, if you take a look at your calendar, 9th of May is Tuesday. Your exam is on Tuesday, 9th of May, okay? As far as I know. And my suggestion for the revision session is 4th of May, which is Thursday, the the week before. So 4th of May between 12 and 14, between noon and 2 p.m. This is my suggestion. Does it work for everyone? If you have any objection or other revisions so far, if tell me just to
Would you be able to do it Monday and the 8th of April
it's too
as a
late, isn't it?
8th of May, I mean.
Yeah,
Yeah.
it's too late.
It's too
Sounds good.
late because
The day
the
before.
exam will be tomorrow. Oh no, it's not possible because it's coronation day. It's bank holiday.
Oh, sure.
8th of day is there is no exam if you have noticed on the exam schedule. It's coronation day and bank holiday. It's bank holiday. So um it's not possible to do on that day. And also it's really late if you want to do that just one day before the exam. So people need some days to just to digest the discussions we make in that day. So I think the best way is Thursday, 4th of May, just to have enough time to recap with any kind of activity you need to do before the exam. Um, yeah, it's just a few days before the exam, and it helps to solve any issues students will have. So I'm just asking if you already have agreed with some other revisions on that day, you can just tell me. Otherwise, I can fix it. We can fix it together. Just if you have any other
Yeah,
revisions, is it good? Does it work for everyone?
I have a question.
Yeah, go ahead. Walid, go ahead.
Yes, are the exams date confirmed?
I think so. Yeah, I have the file on my desktop. I think so.
They just mentioned
Um,
exam the day before. So just to confirm that if we do the revision,
see,
it's not.
let me open. I think you can. It is on the website, and let me just open this file. Ah, this is on university website, and this is the whole exam schedules. Can you see? Um, say it is Tuesday, 9th of May. This is you. CIV 0008 between 9:30 11:30. The exam is in Hilkington 011 LT room on the Medway campus. This is you, right?
What about the week before? When is the exam for that, for the other subjects?
You can download this from the website. It's for all the subjects.
Okay,
It's not only for the civil engineering. You need, if you want something specific, you can tell me. I can find it for you. But it's a big file, 22 pages with all the exams on the campus. So it's not only for civil engineering. It's for everyone. And I can. Where is the um? I can put it on the chat, I think, if it's possible. Let me see. How can I do that? Here it is. It is on the chat, right on the in the chat box of the call. You can download it.
perfect.
Um,
Thank you.
just to be sure, this is the revised version because there was a revision, not for you, but for uh, one of the, yeah, this is the revised one. These red ones are were modified after they realized there was a clash between some of the exams. So, for example, yes, 21st of April. Yeah, this is the latest file I downloaded from the website. So you can check it by your own as well. I just downloaded from the website in the exams section, and I assume this is the final one. I think everything is inside this, and you can find all the exams and dates and times. And yours is on 9th of May, so I assume that 4th of May work for everyone well for a kind of revision session for for the exam. And um, is there any question so far? The last point, not the least, you have received an email from me a couple of days ago about the EVSIS survey that you have received the corresponding email. And the contribution of students was not very high in that time. I don't know today, but I'm kindly asking everyone just to spend a few minutes to fill up those survey forms. It's really the right time for you to speak out if you think of any sort of constructive comment or suggestion for the module to be better in the next deliveries. I mean, the next year, or even in during the exam, during the possible resit, whatever is related to the teaching and learning processes. And it's really appreciated if you do so, because however it's not mandatory, but if you do so and provide uh, me with comments, I'm really happy to receive any sort of constructive comments. I always use those comments to enhance the quality of the lectures delivered to students. So it really matters, and it's the right time for you to think of any sort of comment, suggestion, uh, any sort of ideas you can provide to me to and the university, of course, to be used for further enhancement of the module. And if you do so, it's really appreciated. This was from me, and I don't think any of other comments or issues I need to discuss. So uh, everything. Walid, did you say anything?
Yes, yes. I have a question. Do you
Yep.
remember a while back we spoke about the previous coursework because there was a
Yeah.
misunderstanding?
I will correct them. I will correct them when I'm marking the second part together. Okay.
Okay, you just wanted to make sure that.
Yeah, yeah, it's on my to-do list, and don't worry about that. I will recheck all the first part of your coursework with the second part when I'm doing that. Don't
Oh,
worry about
that's fine.
those marks. I will revise all the marks, but it's more fair to do it together when you submit your second part of the coursework. So it better makes sense just to not to miss any part of the coursework and not to miss any part of the student's work. So it better makes sense if I do it at once at the same time or everything together.
Okay,
So don't worry about that.
yeah, don't know.
Um, Otherwise, again, I just emphasize that where is the Moodle? So I just emphasize that uh, really everything is on the Moodle. So you can really find everything about the lectures, Excel files we have implemented during the different parts of the lectures and the pre-recorded videos, especially these recent ones I've uploaded. Also, in the tutorial and exercise sections, you will have some useful materials, and in the resources and materials, and in the coursework submission, I've already created the second part for you to submit your work, and you will submit your work here, and I will download your work and I will mark them here. Okay, and this is your no, sorry, no. This is the brief. This is the Excel sheet for the parameters. No, I will mark them here. You will submit them here. For the first part, I had to create another one for some reasons, just to include the rubric. But this is okay. I don't need to create another one. I can do it within this. For the first part, it was a technical problem that I created a new one, and the marks are here. So, but for the second part, you just submit your work here until 28th of April, and um, I will mark them here as well, and I will announce everything by using the uh, module news and announcement here, which send you everyone actually an email. So uh, I just emphasize that please read your emails you receive from me through the module news and announcement. So just spend a few minutes to read them, and if there is any necessary action, just do it, please. And that's the most appropriate way of the mutual uh, communication between me and the whole module students. So if you receive something from me, please just read them and be careful about the content. That's it. And I will do my best to communicate with everyone about any kind of activities we have or any kind of updates about the module. For example, when I mark the module, the coursework, I will let you know by an email. Okay, I've done this. You can go there, take a look at your marks. If you think there is any problem, just let me know, and we will be in touch all through the whole journey until the end of the module, exam, coursework, whatever it is. And I really hope you all will be successful at the end of the module. I hope so, but it really depends on your efforts you're putting on this module. So it's a really important time duration during the coursework submissions, exams, and etc. So try to do your best, and hope you all the best for your endeavors. Is there any question from anywhere, from anything?
Yeah, I have one question, two
Yep,
questions actually.
yep.
So in the exams, we have three questions, each question containing about 33 marks.
Yes, there are three questions. Actually, two of them are 33, and one of them is 34, just to be 100. Yes.
Okay, and it will be only about trusses, no beams and no frames.
Yes. Um, I I didn't want to reveal this, but randomly it's revealed by that appendix. Yes, that's correct. Yes. It is about the questions. No, no, it's not correct. No, it's not correct. Um, you will have some beams or frames by using the methods rather than a stiffness method. For example, for using Castigliano or virtual work, I can ask you a beam or a frame to be solved with Castigliano or virtual work, for example, or a beam solving by integration method. So there will be a beam or a frame. But for the matrix analysis, yes, it is only uh, truss structures. Does it make sense? Mahat, does it make sense?
Yeah. Um, and one more thing. So we don't have a lecture after this.
No, we don't.
Okay. So all right. Okay.
Because next way
So
Friday is a Good
So
Friday,
we,
and
so we leave
so
it here.
so it should be just one question about stiffness matrix, right?
yes. Yeah, obviously there are three questions. So one is about stiffness matrix. The two others are about the other methods like Castigliano, virtual work, integration method, etc. Yeah. Does it make sense?
Yeah.
Yes, yes.
In the question, let's say there's question one. Could it be like, for example, you asked in question one to solve the beam with virtual and then with Castigliano, and that's one question.
I haven't done that, but it can be. But I haven't done that. Uh, no, it's not like that. But in one of the questions, there are some subsections like solve this beam with, let's say, virtual work method or Castigliano method, and obtain the support reactions. Then in the next section, obtain deflection in that point. In the next section, obtain the whatever in another point. It can be like this, asking for different things in one question. But principally, it can be like you said, but I don't think I've asked like that.
Thank you.
Any other question? So if there is not any other question, we wrap up this meeting today, and I hope all of you the best for your endeavors in this module. Have a nice rest of your day, and bye-bye.
Thank you so much.
So just one last question before we
Yep,
go. If you have
yep.
any questions about the coursework, we can still email you, right? And you'll respond back, right?
Yes, that's correct.
Okay.
But if you had too many questions, I mean, everybody had too many questions, I can set up another session on Teams for discussing different things, but it depends on the cohort. So if you, I have no idea if you are connected together or not, but if you really felt that it's good to have another session for the coursework, we can arrange that as well.
Okay.
But just let's decide about this when you actually start your coursework and came up with some problems. If you thought that this would be useful, we can arrange a meeting about the coursework as well.
I think that might be useful, but that would only be possible after the 14th of April, because until 14th of April, everyone's got to do the final year projects and other three more courseworks. And so yeah, if something like this happens, it will be after 14th.
Mhm.
Yeah.
Okay, okay, okay. We will see. Anything else? Okay. See you later. Bye bye.
Thanks, bye.
Thank you, sir.